Thanks again. All right. Our next speaker is Dr. Fabian Michelangeli, the Abbess Curator of Tropical Botany at the New York Botanical Garden. As was mentioned earlier, he earned his PhD from Cornell University and was later a postdoc at the American Museum of Natural History. While most of his current research focuses on systematics and evolution of the Melastomataceae, he has also worked on floristics and ecology of the Guyana Shield. And today he'll speak on endemism and adaptations in the flora of the lost world. Fabian.
Well, thank you, Eric, and the rest of the committee, Susan, Janelle, Liz, etc., for the invitation. Now I feel a little more relaxed than 20 minutes ago. So yeah, I'm not talking about melastomes. It might be the first time in, 20 years, or 15 years that I'm not talking about melastomes. And I'm talking about really what got me into botany, which is the flora of the lost world. And there are many places on Earth that have been called the lost worlds, but when we talk about the lost worlds, here we're talking about the Guyana Shield, which is this area north of the Amazon River, south of the Orinoco, in southern Venezuela, northern Brazil, part of Colombia, and the Guyanas. And it's not only that whole entire Guyana Shield area, but more specifically, these unique table form mountains. These mountains are known in Venezuela as tepuis, which is a word in the Pemon native language that means mountain. And since most of these mountains had this shape, they call them tepuis, and then now we know them all as tepuis, even in areas where the Pemon don't live. They're famous for many things, but among them, they are, with those huge cliffs, lots of water. They are, for example, one of them, the place where Angel Falls, the tallest waterfall in the world, comes down from. Tepuis were first explored by Western scientists in 1884 by Ephraim Imthern, who hike to the top of Roraima, and this is a wood carving from his publication. And this is the very same route we take today if you go as a tourist to the top of Roraima. Since the very first moment he got there, he realized how unique the flora was. And in his first report, this is very clear how the forms, the families, the species that he was seeing, they had nothing like that acute that he could compare of. And also, not only he went into great details talking about the flora, there is also a lot of details talking about the great towers, the great rock formations, and even the strange things that they might have seen on the top of Roraima. Whether or not they were dinosaurs is yet to be, the jury is out on that. And shortly after that, about 15 years after that, Conan Doyle wrote a book not as famous as his series of detective novels of Sherlock Holmes, but famous enough, The Lost World. And this is centered in Roraima. And for those of you that have read it, you know that there are dinosaurs on top and all those sort of things. And that's how this notion of the lost worlds for the Guyana Highlands got into the literature. There might be some of you in the crowd that are a little bit younger or that have younger children and never heard of this. And maybe your knowledge of the lost worlds come more from the movie Up, where they go up in globes. And you can see similar waterfalls and towers and the same things. And in a strange case here, before Ephraim Imthern got to the top of Roraima, a few years before, two explorers, Appin and Brown, happened to be at the base, said, well, this is impossible to climb. Maybe a hot air balloon will be the trick. So maybe Up was following literature from 150 years early. So the tepuis, why are they, what makes them so unique? So part of it is its geology. This is taken from a National Geographic from over 20 years ago, but the oldest tepuis are on top of, as I said, the Guyana Shield, which is a very old, over 2.5 billion year old formation, mostly igneous. And on top of that, there is a, let's say, sandwich of sandstone that is about 1.8 billion years old. And that was mostly underwater. And then as Africa started separating from the Americas, that started to come up, and that was the whole Roraima Plateau. So everything we see today as are relics or as tepuis are really relics of this big plateau that then got washed out during the past 20 million years or so during the Neogene. And then you get your typical tepui shapes, which is the surrounding savannas or forest with a series of walls, and then towards the top, the more flatter summits. And this is what, if you Google it and good for, tepui landscape, this is the more typical thing. But really, tepuis, there's about 40 of them, or 45 summits, and they range from only, a few hundred meters across to a few, a couple dozen miles across, so quite a variation there, and also vary quite a bit in elevation. So they're as high as over 3,300 meters in Neblina, and some of them are barely above 1,000 meters. But in addition to those exposed areas, there is a huge amount of different plant environments with scrublands, flooded areas, rivers with very low pH, and blackwater rivers with gallery forests around, and also these very deep crevasses full of arboreal vegetation. So from the beginning, that very first report by Ever and Im Thurn on the Roraima plants, there was the clear knowledge that the plants from the top and the plants from the bottom did not look alike. And this created a lot of interest, and a series of expeditions started in the 30s and 40s, but then really, got really fast in the 50s when Bassett McGuire at the New York Botanical Garden and assembled a team of collaborators, and they started going to as many summits as they could. And then there was a very clear delimitation of the flora of the top and the bottom, and I'm gonna get to that in a bit. But interesting enough, the thinking of the tepuis as a unique area did not come about until two ornithologists, Ernst Mayr and William Phelps, coined the word pantepui, meaning all tepuis. And they said, even though they don't form a contiguous area, these are the flora and the fauna, and they did talk about the flora, is a more homogeneous thing than just thinking of them as Amazonian or lowland savannas that surround them. So the term pantepui was coined and started to be used. The problem with this is that tepuis, as I said, come in all forms, shapes, and sizes. And then what is a summit? What is a tepui? So in this one shot here, there are 6 different tepuis in the northeast more part of where all the tepuis are. And the one in where I'm standing taking this picture is Murosipan is over 2,000 meters. And then the one immediately east of it is only 1,200 meters. So where is the edge of a tepui? And what is 1,200 meters in that tepui is the surrounding forest for another one, or is the slope for another one. And then there are even some tepuis that are so low that wouldn't really go into the classification of what is a tepui. And there are the two extreme ones in Colombia, the Chiribiquete or the Macarena, or the Tafelberg in Suriname, that are barely over 1,000 meters. Those, if they were in Venezuela, they wouldn't have been thought of tepuis, but they are table formed, they are sandstone on top of the igneous rocks, and they have a very characteristic flora. So Ricardo Rina led this study that with Paul Berry and a few others, me included, where quantifying all the plants on tepuis, and we struggle as to how to what is a tepui, but bear with me. And you know, the numbers of genera and families keep changing as APG and people like me keep changing the limits of genera and families, but the numbers of species are pretty good. And we have about 2,600 species that are considered to be on Pantepui. And of those, about 885 are endemic to the summits. And if we extend, we get a little bit creative and say that the summits go all the way down to 1,200 meters, then there's more a little bit like 1,000, 1,100 species. 640 of them are endemic to a single summit. And that's easier to quantify. And when we talk about, you know, 2,600 species in the large context of the flora of Venezuela, that's about, you know, it's just a little bit over 10% or 15% of flora of Venezuela. It doesn't seem that significant. But Pantepui as such is only about 10,000 square kilometers in the Guyana Shield, which is over 1.5 million square kilometers. So it's really, really a small proportion of the entire thing. 10,000 square kilometers is smaller than, it's about Connecticut plus Rhode Island put together. And 1.5 million is about Texas plus Oklahoma plus maybe Kansas as well. So to give you an idea how you get over 2,600 species in this very reduced area. And then when we look at how the species are distributed, as I said, we have a lot that are in a single mountain, and then a much smaller proportion in 2 mountains and 3 mountains and so forth. And then we have a nice sizable number of species that are in many mountains. So there seem to be some widespread tepui species, but then at the species level, there is a lot of locally endemic. And when these are the names of different mountains, and when we look at them in white, the total bar is the total number of species, and in black is just the endemics. Yes, there is a proportion that usually the higher the number of species, the higher number of endemics, but it's not perfect. But what is a very good correlation is that when we look at those mountains is how isolated they are, in particular, how different they are from the surrounding savannas. So, for example, we have a much better relationship between the base summit difference and the number of endemic species is a much clearer correlation. But also there is a correlation with the total number of species and the total number of and the area of those tepuis. And this will be a classical island biogeography example here. Now, there are some caveats on this, and part of the problem is that, again, we don't know how to define tepuis and stuff, but also sampling effort here is huge. And some easy, like Roraima, where you can hike up, have thousands of specimens in the herbaria. Chimantá, you can only get by helicopter, but because it's a large summit, has probably been visited a few hundred times. And then you go to a place like Huachamacari, which is only reachable by helicopter. It's been climbed, but by climbers, not biologists. That place has only been visited probably less than half a dozen times. So the sampling effort is a big issue here. And how do all of these tepuis relate to each other so here we have in black are the bigger ones. Some of the smallest ones you can really see because they, as I said, they're very small. But there is one over there, and it's over the top right that says Los Testigos. That's like 7 of them there in a row, but they're all tiny. But you can see more or less where they are. And this is just a cluster analysis by presence, absence of species of how the tepuis are related. And there is a lot of geographical cohesion here. The things, they seem to form this block, and they are all, there's some very good cohesion, but there are some wacko outliers. And those are probably, well, those 2 mountains in particular are a lot lower than the other ones. So the way they relate to their flora is not as clear. But also that particular one, Aratitiope, has only been visited like 3 times by biologists, maybe a lot more by adventure people, but not by biologists. So then there's very few herbarium specimens to really place it or how it's related to the rest of the things. So what are the families that are in tepuis? So the usual suspects, if you go to any tropical place, be it Amazonia, the Andes, Central America. So orchids, melastomes, rubiaceae, composite, not unsurprisingly, are towards the top. What is a little bit surprising is what is not here. So for example, Fabaceae and Euphorbiaceae are two very large tropical families that are conspicuously absent from the top of the tepuis. And then there are some families that are not as common usually, but are a very important element of tepuis. For example, the family Cyridaceae, the family and the family Rapatiaceae. These monocot families that are usually not that common, they are very common, and they're very dominant, in fact, on top of the tepuis. So something about the tepuis is that because this sandstone has been there for considerable, 1.8 billion years and has been leached for the last at least 20 million years, they're very poor in nutrients. So the soils in tepuis are very low in nutrients. Nitrogen is a major limitant, and with no legumes, or very few legumes on top, it becomes even more problematic, and extremely low pHs. That also means that whatever organic matter accumulates doesn't get degraded very quickly. So there are certain groups that seem to have thrived there, and very interesting, there are lots of families that are represented by a handful of things, and then here I show you a few other examples of tepui plants. So Terrassonium, for a long time it was like, oh, this thing doesn't look like anything. Well, it's just another Pteridaceae now. Sorry, Eric, I guess, responsible for this kind of things. But then, orchids, bromeliads, etc. In bromeliads, it's very interesting because there are a few genera that are endemic, and that particular one, Navia, is actually quite diverse in the summits of tepuis. Families like Asteraceae that are completely cosmopolitan. One of the things that is fascinating is that many of those cosmopolitan groups or tribes that are very common in the Andes or in the Amazon are not the same groups that are common on top of tepuis. So these three genera, Chimantea, Stomatocheta, and Gongylolepis, are endemic to the Guyana Shield. They can be on the lowlands as well, not only on top, but they are characteristic elements of the tepuis, and they're not, they used to be in the tribe Mutici, now they've been moved somewhere else, so when we start to look at all these plants, and here we have, Cyrilaceae, Ericaceae, even Ognaceae here, closer to me, doesn't really much to Ognaceae, and probably Monetiaceae, one of the most characteristic tepui things, is that the combination of high elevation, high radiation, low pH and low nutrients or few nutrients has created this syndrome of tepui plants, which is common in other high elevation places, of usually very small, thick leaves, very few things with compound leaves, and high specific leaf area and things like that. But it's interesting that there is this big convergence. And even though this is also happens a lot in other high elevation tropical mountains, like in the Andes, they happen at a much higher elevation. So to start to get this type of scrubland in the Andes, you probably have to go over 3,000, even 3,500 meters, when in tepuis you get that already at 1,200, 1,500 meters. And perhaps one very poignant way of looking at this issue of low nutrients is the amount of the diversity of insectivorous, of carnivorous plants in the tepuis. And we have here 3 different families represented, Saraceniaceae, Lenturariaceae, and Drosseraceae. And it's not only different families, but completely different trapping mechanisms. You have the pitcher trapping mechanism of Saracenia, you have the sticky flypaper mechanism of Drossera, and you have the modified bladders in the underground stems of Lenturariaceae that, that bladders that suck up their prey. So completely different. And this is part of that issue of having very low nutrients. And very interesting too, tepuis have what is thought to be fairly unique, although there's been recent discussion of this, of carnivorous plant in the monocots, which are these bromeliads, Brocchinia reducta, which are also derive a lot of their nutrients from the insects that are trapped inside them. And so this can be, these communities of insectivorous plants can be in rock environments like this, or in huge bogs like this one in Huachamacari. And something you cannot see here is that some of these Eliamphora tatei are about 5.5 feet tall, the individual plants. Very, very impressive. And the other thing is that you find those insectivorous plants all growing together among a few things. And here, I don't have a pointer, but the purple flowers are utricularias that are growing inside the bromeliads. We have Eliamphoras towards the bottom, and then we have the Brocchinia as well. So everything, and some Droseras as well there in the picture. So everybody growing together. So the family Lenturariaceae is also an interesting example of how a plant family that is successful in a place has occupied many environments. So we have utricularias, the small flowering ones that are usually in sandy soil, and you can, those are the most common ones. We have some epiphytes, like the one in the top center, another soil one, Utricularia quelchi here in the bottom. And then there is a group, a few species that have specialized in growing inside the bromeliads. And in fact, inside those same bromeliads that are insectivorous. So they already have a good broth there full of nutrients. And not only they can take nutrients from what is there, but from other animals, and protozoans and things that come in here. And you can see those underwater branches with the bladders there in the top and the bottom left. One of the things that the Lenturariaceae also is a good example is to ask the question, where do plants in the tepuis come from? And so unfortunately, access to the tepuis, and I will get back to this in a few minutes, has been restricted a lot in the last few years. And sort of missed the boat on molecular phylogenetics, the collecting. And there are very few studies that include a lot of samples from tepuis. But for whatever little we know, in Lenturariaceae, these are not all one clade. They belong to different parts of the genus, and they have come several times from the lowlands into the highlands. And then there are some groups where there are better phylogenies, and every single pattern you can think of relationship of the flora has been revealed here. So for example, Bonnetiaceae, this has, most of the species are endemic to tepuis, and then it has a couple of species found in Cuba. So a very interesting disjunct situation there. In Ericaceae, there are a few endemic genera of Ericaceae, and then most of them are sister to Andean groups. But then we have some Gaultherias that are actually more closely related to the wintergreens group from Eastern North America. Then we have Savalhesia here, which is a large genus in all sorts of rocky environments in Latin America, so going into the Campus rupestris as well, and in eastern Brazil. And in that case, the plants, the tepui plants are also very closely related to the Caribbean and the Greater Antilles one, so a little bit like Bonnetia. But there doesn't seem to be that the Caribbeans are derived from the Antilles. Here seems to be more like a sister relationship. And this is in Salvajesia is the only one for which we really have a recent study published just last year, part of the PAFTOL project that shows that that has phylogenomic type data. And then in Myconia, my own unpublished studies here is one of the few places where we see plants on the top of the tepuis, basal, and the ones down below more derived. Rapatiaceae, again, one of those families that is rare. Elsewhere, here is very common, and it seems that there have been multiple introductions from the lowlands to the highlands. And when they're coming from the lowlands, they always come from sandy areas, not usually from the Amazon. And then Saraceniaceae also presents a very interesting case because here we have, you know Eliamphora, I shown you from the tepuis, and the sister group of that is Eastern North America as well. You guys know Saracenia grows around here. And then sister to those things is Darlingtonia from the West Coast. Try to wrap your phylogeographic or biogeographic brain around that three area conundrum. So access to one of the biggest problems that tepuis are having right now is access, and the Venezuelan government has really restricted access. There's very hard to get permits, and then mining operations starting to happen and a lot of degradation. So unfortunately, as I said, all of this happened when the molecular systematic wave came, and so we still have a lot to learn, and before this environments get more trampled. A lot of what I talked about today is in this book that came out last year, edited by Valenti Rule, and as I said, on a paper that I co-authored with Ricarda Rina. Thank you. I think we have a minute or two left. It's off.
It's off, of course.
Now it's on.
Now it's on?
Yeah.
Okay, thanks, Fabian. Are there any questions?
All right, David asks, have there been any studies on the problem of island biosecurity when visiting tepuis? Is there any evidence of visiting biologists introducing invasives, arthropods, soil microbes, fungi, etc.?
So the problem of the actual biologist hasn't been studied as far as I know. There is a recent paper I saw on soil microbes, but they did find some cosmopolitan soil microbes, so it's hard to know if those were brought in by us or they were brought in by others. A problem that is as big as Roraima and Kukinam, where people can literally just hike in from the road. It's a 2-day hike, but you can just hike in. And the areas where the tourists go, there's been issues with water quality and human waste that have become a problem more than biosecurity, I say.
I have a question myself. Any evidence of climate change impacts? Is it getting drier, wetter, hotter?
Very good, and in fact, in that book that I mentioned, that there is a little bit of discussion about that. I mean, it's getting warmer, but the problem is that because there is very limited amount of monitoring on top, it's very hard to know that precisely. The dam company that runs a Woody Dam farther downstream from all of this used to have a lot more control about that, and there's very good data up to about 2010. But even though they keep collecting the data hasn't been as available for the scientific community afterwards. But the data at least is being collected for a couple summits. Yeah.
My turn, thanks. Maybe two questions if I could. One, since the plants are so unique there and like you said, a high level of endemism, do you find that the insects and the pollinators that are there as well have also high levels of endemism?
Yeah, so for certain groups, for example, water beetles, which are not pollinators, but for water beetles, there are some good studies, and the level of endemicity is much higher than for plants. But on the other hand, the level of endemism for birds is lower. So it depends on the biology. You know, birds can move a little bit up and down, and these water beetles are very restricted to the pond where they hatch, where they lay their eggs, and then they live their life story. So yeah, it's not only plants. For frogs, high levels of endemicity. So it's across the biota. And there are even a lot of descriptions of, well, not a lot, but quite a few of grasshoppers. So it depends who the specialists have been, but it's not restricted to plants.
Thank you. The other one is, you said Venezuela restricted access to the tepuis. Are there, do the countries have a higher level or some level of protection, you know, parks or whatever, to protect them?
Yeah, so almost all, not all, but almost all tepuis are within either national parks or preserves, but the restriction is not out of concern for the environment, it's out of a policy of not really authorizing research. Because if a tourist gets to the base of a mountain, there is really no enforcement. The tourist will walk to the top of the mountain. And in fact, there was a very recent paper on Saracenia Phylogeny, and every plant, well, not every, but almost every plant cited or used in that paper was collected by, not by the author of the paper, but by illegal collectors that go by helicopter and then is profitable enough to then sell those plants in the market, in the carnivorous plant market.
Do I have one more? Yeah. Because the continent's separated there, do you find similar formations and growth in Africa, where they used to be connected?
So there are similar geological features, but they're much smaller. They're not as in Western Africa. They're not as big as this, and in the sandstone layers, it's only a few hundred meters, not 3,000 meters. It's very different.
Thank you.
One real quick question. You mentioned mining as an issue. Dennis asks, what would be mined from the tepuis, which are sandstone?
So that nothing from really the top. There's some people that have attempted to mine for diamonds on the top, but the foothills, there are lots of gold and diamond mines right around the foothills. And then they are always adventuring all the way up to see what they can get.
All right, so we've arrived at our first break. It's about a 30-minute break. We will be reconvening right here in the auditorium and online at 2:45.